Hello and welcome everybody. Today in this video we are discussing chapter 5, which is under the title of sewer system. So first of all, let's have a definition of the sewer system. Sewers, it's any underground infrastructure or any underground conduits. Those are responsible to convey the wastewater and stormwater to the treatment plant. So we have two systems. We have the wastewater conveying system, and also we have the stormwater. Stormwater means the rainwater. So this is the sewer system. It's all the infrastructure underground to carry the water to the treatment plant until the point of disposal. So basically we have two main categories of sewer systems. The first category is the separate sewer system, which means that two separate types of sewers. One system for the domestic sewage and the other system for stormwater. They are completely separated from the collection point to the plant or treatment until the disposal. It's totally separated. Okay, so and then domestic sewage flows to treatment plant. Stormwater discharged untreated. This is widely practiced in Malaysia. Why? You can guess why the stormwater system is separated from the sewage treatment system in Malaysia. Now imagine or considering the weather in Malaysia, how it looks like. Almost every day there is rains, storms, thunderstorms, and so the amount of rainwater or the intensity of rainwater during the year is very high. So that makes it more economically and more safe to make a separate system of collecting the stormwater, discharging and treating the stormwater, separated from the sewage treatment and collection system. On the other hand, we have the second category, which is the combined sewer system. In this combined sewer system, we have one system combining and collecting the sewage treatment, the sewage, wastewater, and the stormwater. They are combined and collected in one sewer. Okay. Here, if we have large quantities of stormwater, of course this will make the sewers or the pipelines will make it very large and very huge. Okay, so in this system also we expect to see high flow into treatment plant during storms, and this is logic because during storms we have that both wastewater and stormwater, they are in very high quantities. So the plant or the treatment plant must be designed to receive such quantities and to be able to treat them efficiently. So this is the diagram of the separate sewer systems. Here are the buildings, the residential buildings and other types of buildings. So the wastewater is collected from the buildings and then sent to the wastewater treatment plant. After treatment, it will be disposed, while the stormwater is collected through catch basin or any kind of collection system. Okay, so it will be disposed untreated to the river or to disposal point. So this is the separate system. On the other hand, we have the combined sewer system. It shows that the collection is combined in one sewer or treatment system. So we have also the treatment system is combined, and then it will be disposed to the river. In sewer or in the combined sewer system, there must be a bypass point, okay, through weirs or through dams. This to allow the wastewater to overflow through pipes to go to the disposal point directly without wastewater or without treatment. This could happen at the time of peak storms, at the time of very high intensity rains. In that case, if the wastewater treatment plant is not able to receive all the quantities of the combined wastewater and stormwater, so there has to be bypass lines to dispose the wastewater and the to dispose the wastewater and the stormwater to discharge points until the peak or until the rainwater is getting low, so we go back to the normal situation. Okay. All right. So this how it looks like for a combined sewer system. It looks very high, very huge. The diameter is very big because we are expecting to expecting both of sewer system sewage treatment, sewage wastewater. We are expecting sewage wastewater in addition to the stormwater to be disposed in the pipelines. Okay, now let's have a brief discussion about the location of sewers. Location of sewers, it has to be placed in locations that allowed for maintenance purposes. So the best location of sewers is within streets. So normally sewers or pipelines, it will move with the street, or it will be governed by the street directions, by the street network, the road network in the city. So this is the most proper and adequate place to be located. Here you can see that some maintenance is being done for sewers, and the maintenance is taking place in the street or within the street through point or through access point. We call them manholes. So what are the manholes? Okay, manholes, those points that permit the inspection and cleaning of sewers and removal of obstructions. So through these manholes, workers can enter and access the pipelines to do any maintenance and cleaning works. So these are some shapes of the manholes. So let's have a look. Where do we place the manholes, basically? So here we have the 4 main locations of manholes. At every change in direction, at every change in gradient, at every change in the size of sewer, and finally at intersections and junctions. So let's discuss them one by one. This is a simple schematic diagram that shows when the sewer need to change the direction, it has to place the manhole. Okay, so this will facilitate the change of direction of the sewer. We cannot place such fitting or elbow to change the direction. Simply no, it has to be a manhole. Okay. In the second situation, in every change in gradient, normally placing the sewers will follow the land surface or the topography of the surface. So wherever the surface is straight, we can put them almost straight. And but when the topography has land, steep landsliding, or the gradient is different, either to down or top. So the gradient also of the sewers has to change. So changing the gradient, as you can see here, this is a side view. We must place a manhole. Okay, we must place a manhole to facilitate this change in gradient. Okay. Also, in every change in the size of the sewer, we must place manhole, as you can see here in this side view. So from small diameter to larger diameter, or vice versa, from larger diameter to smaller diameter, also the same. But normally it is from smaller to larger. Okay, this is the normal. This is the normal case. So we must place a manhole in that case. And also the fourth case, at intersections, junctions, when you walk in the streets, you can see it very commonly at junctions and intersections. There are manholes, and these manholes will join two intersecting lines. Okay, so two or maybe more than two lines joining together in one manhole. Sometimes 3 or 4 lines joining in one big manhole. Okay. Now, where should we place these manholes? It has to be also placed if the pipeline is straight without any change in direction, without any change in diameter, without any change in the gradient. I mean, we are following a very ideal case, which is the straight pipelines. If the pipeline is going to be straight more than 100 meter for the diameters of 200 millimeters, okay, and above, so every 100 meter we must place a manhole. And also for the diameters that are larger than 450 millimeters, we can place the manhole up to 150 meters. Every 150 meters there must be at least a manhole. Okay, why we must place a manhole, although there is no any reason to place a manhole? There is no change in size, diameter, gradient, or anything else. So here we can say that this manhole is only for maintenance. It's only for maintenance. Imagine that we have a 500 meters or 1 kilometer of straight line. So if a blockage happen during this long distance, so how are we going to inspect and to detect the exact location? So placing such manholes will facilitate and will make it more easy for the maintenance work to take place. Okay, now we move to one other component of the sewage treatment system, which is called the pumping station. Those are huge pumps located in some places. The main function of this station is to pump the wastewater from location to another. If the topography of the area does not permit the flow of the wastewater by gravity, okay, because the normal flow of wastewater is by gravity only. It's not using pumps. But if the topography of the area does not allow the flow of wastewater by gravity, so we need to pump the wastewater from downstream to upstream. Okay, from downstream to upstream, so we have to transfer it by using pumps. Okay, the second reason is excessive construction costs due to deep excavation. Now, normally when we place the sewer lines, we have to make it slope. Okay, we have to produce a slope. It cannot be placed horizontally with zero slope. No, there has to be a slope at least 0.5 or 1%. Okay, 1% at least. So from point to point, okay, after certain distance, we must do large or huge excavation work in order to place the deep lines. Okay, so at this point, this is the land surface. You can see here, this is the land surface. So at these points, the excavation cost is not so high. As at these points is getting higher. But at this point, you can see there is a lot of excavation work that has to be done. So what should we do here? We have to, or we must place, or we must do deep excavation, and this will make it costly. So at some point we can place a pumping station to transfer the wastewater to a higher stream, and then continue again from a more shallow point. Okay. Generally, pumping stations should be avoided, okay, because the installation, maintenance cost, operation is expensive, so we have to avoid it as much as possible. Okay, now let's have a look about this real map. I'm going to explain the idea or the concept of sewer system distribution, sewer system locations, and also the location of the pumping station. Okay, now this is a real map. Here is the main road. Okay, this is the main road, and this is the STP. This is the sewage treatment plant. We're going to see what is the directions of sewers that will serve this area, this residential area. Okay, so these green lines represent the topography of the land. Okay, so using this topography, we must place the sewers. Okay, so the sewer in this area is heading in this direction. The sewer in this area can be heading this direction, okay, you can see. So this line actually represents like a top hill. Okay, it's like a top hill or a peak point or a summit. Okay, and also this is the direction, so it's going down here, down over there. Okay, so we cannot send all the wastewater directly to the treatment plant, as you can see. From this area, yes, we can send it, but from other areas it's difficult. We cannot oppose, and we cannot go or contradict the gravity and contradict the topography. Okay, so what we can do here is to place pumping stations. So if we place, the wastewater will move by gravity from these points until it reaches a pump station. This area, the wastewater will move by gravity like this until it reaches pump station, and here also as well the same. And from pump stations, wastewater will be sent through pumping lines to the STP, to the wastewater treatment plant. This one will be sent directly. This line and this line will join in one line, and then will be sent to the STP, the sewage treatment plant. Okay, so you can see here how the location of the pumping station is playing a significant role in the sewage treatment or in the sewer system. Just in a small area, we are placing 3 pumping stations in order to be able to transfer the wastewater to the sewage treatment plant. Otherwise, we might need to construct a sewage treatment plant separately for each small area, but this will be costly and it's not efficient, it's not feasible. This is the end of chapter 5. Thanks for watching and have a nice day.